Hi, algebra students. I just sent you a link on Google Classroom to a good Khan Academy video to help explain how to graph exponential functions. But I decided I would go and do one from your homework paper too. Your homework page. On page 427, I was going to work through number 11 with you guys. Okay, so over here on my paper, excuse my chocolate here, I've been snacking. Number 11, so in order to graph an exponential function, you have to create a table of values similar to when you're graphing a linear equation, which you've been doing for a couple years now. So, and that's also going to be the same when you're graphing quadratic functions too in the next chapter. But so you get to create your x values. So if you look, you'll see that they often will just choose, like we did with linear equations, choose some negatives, choose 0, choose some positive values, and then I have them worked out here just to save time so I can explain. So some of these x values are going to be a little bit more complex, for example, like this one. So if you plug in -3 for x, which ends up being plugged in for the exponent, so before on our last day of school, I talked to you briefly about a negative exponent. So look that over again in your book if you forget what we're talking about here, or if you weren't at school. Or look for a Khan Academy video that helps explain negative exponents. But remember, a negative exponent is, you can get rid of the negative part of the exponent by flipping the base to its reciprocal. So, so 1/6 would just become 6 over 1, right? And then the exponent becomes a +3. So it would be 6 to the third. So from the function above, we'd have 2 times 6 to the third. So 2 times 216 would be 432. So right there already, look at this coordinate point we just created. A coordinate point of -3, 432. You'll see how that happens too. I know that's a pretty big coordinate point, but we're not going to end up plotting that one, but it helps you see the idea of what an exponential function is. All right, so then again, same thing when x is -2. I plugged in -2 for the exponent for x. Okay, again, to undo the negative part of the exponent, I flipped it to its reciprocal and it became a +2 exponent. So 2 times, that'd be 2 times 36, which is 72. So there's a coordinate point of -2, 72. Same thing when x is -1. You can plug in -1 for x for the exponent. That 1/6 flips over and becomes a +6 to the first power. So that'll just be 2 times 6, which is 12. So that's the coordinate point, -1, 12. And then as we talked about on the last day of school also, anytime you have an exponent of 0, that's always equal to 1, no matter what the base is. Anything to the 0 power is 1, so it's just 2 times 1. So that's a coordinate point of 0, 2. And then when you plug in an exponent of 1, 1/6 to the first power is just 1/6. So we have 2 times 1/6. Yeah, that's just like multiplying fractions, right? You just put 2 over 1, then you multiply the numerators, multiply the denominators. You get 2 over 6, which is 1/3. So that's the coordinate point 1, 1/3. And so on. Okay, I'm just going to show this so you can kind of follow my work for the last 2 x values that I used. Okay, so then I did not bring home any graph paper. I don't know what kind of graph paper I even gave you guys. I don't know if it's gonna work well, because if you're gonna have to renumber your y-axis for sure, like I did. So like I mentioned, I am not going to be graphing this first coordinate point, which was -3, 432, because that's just too big of a point to plot. But I went by 10 so that I could plot the next one at least, and we could start to see what it's going to look like and what's going to happen and why it happens. Okay, so go ahead and get your graph paper all set up, and you can go plot these two with me while I do it. So -2 and then up to 72 would be about right there. And then -112. And then 0, 2. And then 1, so over 1, up a third, which is practically not going up hardly at all when I'm going by tens, right? And it's only going to get worse. I go over 2 and then up 1/18. It practically looks like it's going to be on the x-axis, but we know that it's not, right? And then over 3, up 1 over 108. So if you were graphing them accurately, they're pretty much going to look like they are on the x-axis. But again, we know that they're not. So what they say to do once you have this, you can't use a ruler because it's not a straight line, right? It's not linear. So they just tell you to draw a smooth curve. So you're just going to take your pencil and kind of connect the dots with curves. You don't need to make straight lines to connect them all. And then like we always do, that shouldn't have gone up. You can draw arrows at the ends. And back to that first point of -3, 432, you can imagine if I did plot that -3, then all the way up 432, that would be way off my paper, and it almost would look like I was making this line gets more and more vertical looking. It's technically never going to be completely vertical, completely up, straight up and down, but it's going to look like it because it's, if you're going backwards, it's increasing so drastically, okay? So I sent you on Google Classroom a video, explaining what exponential functions is even all about. And I would love for you to watch that, please, because it really helps explain, a real life situation. When the best way to describe exponential functions that everyone can relate to is how disease, viruses, bacteria, they grow exponentially. It's a perfect example of what exponential growth means, okay? Because we all know how that happens. So I would think you should watch maybe 6 or 8 minutes or so. So take some time and watch that, because I think that's going to help too. So this is an example, though, not of exponential growth, but of exponential decay. And hopefully, before you did your homework, you already remember I said make sure you're looking at the key concepts in your book. They give you an example of each of those, right, and what they're going to look like. Remember, we always read a graph from left to right. So this is falling, this is decaying, and this is growing from left to right. So that's why they use those words, okay? So important things to know. If we did, you could keep, these x values could keep getting smaller and smaller if I went backwards up here. And you can imagine these y values would get exponentially larger, right? Just as you can see how much they grew already, right? From 2, 12, 72, 432, right? And then another thing to make note of is that the y value, although it looks like it is, it's never going to reach 0. If we kept putting in more x values that got larger and larger, the y value would keep getting smaller, but it would never reach 0. The fractions would just keep getting tinier and tinier, like you see happening here, but it would never reach 0. Okay, so that's why, you know, they say just make a smooth curve to connect all the points, and your line's just kind of ride right along that x-axis. It looks like it's hitting it, but it technically isn't. Okay, so I hope that helps in terms of how to graph the exponential functions. The other part to those questions in the directions, they ask you to state the y-intercept, and they ask you to say the domain and range. So I want to talk to you about that real quick. So the y-intercept, you all know, is just where the line hits the y-axis. So you can see right here on this point, 0, 2, that's the y-intercept, right? Okay, so the y-intercept is 2. And then the other thing to make note of, that's important idea that I kind of talked to you about already, is stating the domain and the range for each problem. So remember, the domain, they're asking you about what the x values could be. The range is talking about what the y values could be. So as I said, the very first thing, you were allowed to choose any x values you wanted to, right? And then we could plug those numbers in for x and solve. So the domain is all real numbers, because you could have used any number to plug in for x. This graph could go forever, left and right, right? And then the range, the y values, look how I wrote, you know, y has to be greater than 0. All of your y values are going to be greater than 0. Again, it looks like it's gonna, as we go from left to right, it's gonna constantly be approaching 0 and 0, closer and closer and closer, but it will technically never be 0. So y's greater than 0. Okay, if there is another one that I can work out for you, just let me know on Google Classroom, email me, and I can make another video and explain the problems if you need it. Thanks, bye.